Thank you so much, and thank you to everyone for being here. I know it's everyone's lunchtime, so we'll try to go through this pretty quickly so that you can all get your food. As was mentioned earlier, my name is Mingo. I'm a sales engineer at Plotly, which is a fancy way of saying I'm the technical person who does demonstrations and has to know the software really well when talking to people who are seeing it for the first time. I've been in the data and analytics space for about 8 years now, which is kind of crazy to think about. Prior to coming to Plotly, which is more focused on the data visualization, the analytics side of things, I was at a company that was more focused on cleaning up the data. And that was cool. That was a good place to start my career, but I really got interested in what you could do with that information, which is what brought me to Plotly. Throughout my career, I've worked with so many different companies in so many different industries, life sciences, gov, a lot of life sciences here in Boston, healthcare, financial services, too many to name, but it's been a really, really great opportunity to meet people in so many different places, working on so many cool different things. I've been lucky enough to come to a lot of conferences like this one, so I've been all over the world with Plotly. I went across the pond to London a couple years ago, San Francisco for ODSC West last year, and even all the way from Cambridge, where I live, across the river to Boston. So really glad to have a local conference that I don't have to travel as much to. Now, you may be curious about why this photo of me has an apron and a tray. That's because at ODSC West last year, it was actually Halloween when I was given my workshop. So I dressed up as an application server, kind of keeping with the food theme. Yeah, I heard a laugh back there. Thank you. Now, with regards to the agenda today, we have a lot to cover and not a lot of time. So I'm going to try to go through a variety of topics pretty quickly. We're going to start with just kind of the basics of building a dashboard or an application. There are a lot of different ways to do that. And what we're going to be focused on today is how to build one of those applications with code using Python and a library called Dash. So we'll cover all the things that you need in order to build an application. We'll talk about just Plotly generally, all the different stuff that you can use when building your app. We'll go through all the parts of making a Dash application work. And then, of course, AI is a big focus of everyone's here. We'll talk about the different roles that AI can play, both for the development process as well as for the end users. At the end, we'll talk about places you can go to find more information about Plotly and Dash. And if we have time, we'll also do some Q&A before we get you all out of here for lunch. Now, before we get into the meat and potatoes of this presentation, I did want to take just a quick pulse check of the room and get a sense of people's level of familiarity with different ways of building applications and dashboards. So just by show of hands, how many folks here have built a dashboard or a graph with something like Excel? Yeah, not surprising. That's pretty much everyone in the room. Now, on the other end of the spectrum, how many folks here have built a web app from scratch using HTML and JavaScript? Yeah, not surprising. Not quite as many people, although this is ODSC, a lot of technical folks. We have probably more people than the general population. So those are kind of two ends of the spectrum for how you can build stuff. On one end, you have the really easy, you just download something to your desktop, click a few buttons, you make some graphs. And on the other end of that spectrum, you have the full stack developer role, where you need to have a lot more knowledge in order to build these applications. So I know it's almost lunchtime. I wanted to start with a food analogy, just to kind of explain the different ways of building these applications. And on the left here, you have the fast and easy option like Excel. You want to order a pizza, you go to a restaurant, and there's a menu of different options you can choose from. Maybe you can make some customizations, you can ask them to add or remove certain ingredients, but for the most part, it's a pretty standardized process where you kind of know what you're getting. It's going to be fast, it's going to be easy, but a little bit limited by the options that are available at that restaurant. On the complete other side, you have the farm-to-table method, where if you're a farmer and have the resources to do so, you can grow all your own ingredients. Right? You can know exactly what's going into that pizza that you're making. It's going to take a lot of time in order to grow those ingredients, but you're going to have exact control over everything that's going into that meal that you're making. And then somewhere in the middle is going to the grocery store and buying those ingredients. So you still have a lot of that customization at your disposal. You can pick the type of cheese you want, you can pick the type of flour that you want. You get to pick and choose all the different ingredients that are going into that pizza. But you don't have to grow them all yourself, they're all ready for you. And it takes a little bit of knowledge. You need to know how long to cook it for, the temperature. You want to make sure not to burn it. But it's pretty quick and easy, so you kind of get the best of both worlds. And that's kind of the equivalent to Dash. So for those of you who aren't familiar with it, Dash is a framework, open source Python package for building these web applications using code. Now the thing that's really nice about Dash, one, it's all in Python. I guess actually just quickly, show of hands here, how many people here are Python developers? Yeah, pretty much everybody, that's great. So Python is everywhere. It's the language that people are using for data science, analytics, machine learning. So it's a really common language that a lot of people know. That means that you can build these applications without needing to be a web developer. I don't need to know how to write JavaScript to make my functions interactive. I don't need to know HTML and CSS to make my app look really pretty. It's all just in the same language. Now, with that foundation, let's talk through what you need in order to actually build one of these applications. That's a picture that I took, a selfie, when I was cooking pizza a couple weeks ago, so in my apartment across the river in Cambridge. The first thing that you need is just a basic level of Python experience. You don't need to be a hardcore software engineer. You don't need to know how to build a website from scratch. You just need to know a little bit of Python. Reading in a data set, writing Python functions. Now, of course, to build a data application, you need data too. And that's one of the key things about Dash. Like, whenever we talk about what you build there, we usually refer to them as data applications. We make that distinction between data applications and dashboards because they're full-blown apps. You can do stuff within those views that you're building. And that's something we're going to show you a little bit later in a live demo. But you need data in order to build those applications, and then obviously the tool that we're talking about today to build those apps is the Dash framework. So what I always explain to people when they're seeing Dash for the first time is that there are two main parts to making your application work. There's what's on the page, so that's more of the user interface. You say in your code the stuff you want to put on the screen. And then you have the interactivity piece. That's through what are called callback functions, where you say, what can the user do in order to trigger something within your application? That could be updating a filter, that could be updating a record in your database, it could be running a model. We'll talk about a lot of those different applications of callback functions a little bit later on in the talk today. Now, beyond just all that basic stuff, you can add in whatever you want, right? Going back to that pizza analogy. You're able to add your own custom ingredients. You want to connect to a specific type of data source? Import that package into your app. You want to run a very specific custom algorithm. Either import a library that you've already written or just write that code in line in your application itself. That's one of the big takeaways I want to make sure you all have by the end of this session, is that this isn't just some really fixed solution in a box. It really is a toolkit so you can build whatever you want using very simple Python code. Now, just a little bit about Plotly. We've been around for a little over a decade now, and we're really well known in the data science and open source communities. Most people know us for our graphing library, also called Plotly. What's really nice about it is that you can build interactive graphs. So not just images on the screen, but you can actually hover over to get a drill down into your data. You can zoom in on parts that you care about. Interactivity is a really key piece to everything we'll be talking about today. And of course, Dash, the library we've talked a little bit about already, that's that vehicle for really building applications as opposed to individual graphs. So I want to display a nice line chart or bar chart. I can just install Plotly and make a graph run in my Jupyter notebook, no problem. But I want to create a full-blown application where I can run a model. I can update a database. That's what you need Dash for. And you can see in the center here, we work with a lot of different technologies out there. Databricks last year actually did a survey of all their users, and they found that Plotly Dash was by far the most common thing that people used alongside Databricks to visualize their data and get it into an application. So we have tons of people out there using our open source libraries. We've worked with organizations pretty much every industry, every use case you can imagine. So it isn't specific to any type of data, any format, any domain. We work with all sorts of different data sets. And probably the biggest benefit of using something like Plotly is that you have a huge open source community at your disposal anytime you have questions. And a little bit later on, when we're talking about where you can go to find more info after this talk, we'll talk through some of those places like the community forum. All right. So talking about the different parts of building one of these applications, we're starting with the visualizations. That's key to any sort of data science project. And that's where Plotly comes in. So these screenshots here, ironically, are static because it's not a web page, but these are all different types of visualizations that you can build using Plotly. So you have all your standard bar charts, line graphs, pie charts. I know those have kind of fallen out of fashion, along with actual maps. Right, so this is just a sample of the sorts of things that you can build with 1 or 2 lines of Python code. And just so you can see live, this is our docs page that shows examples of all these different types of graphs you can build. So again, you have your more standard visualizations, more advanced things like heat maps, even actual maps. Right? We can work with geospatial data too. And the common thing about all of these is that they're all fully interactive. Right? So I can go in here, scroll down to the code, and you can see it's just a single function call in order to create the map that you see down below. And I mentioned this before, but it's worth repeating. This isn't just an image on the screen. This is a fully interactive visualization. So I can zoom into, say, Boston, where we are right now for this conference, and I can see information about the unemployment rate there. Right, so this is just with the graphs themselves, and you already get a lot more information than you would have with a static image. But where the real power is going to be is with Dash. So I mentioned before, Dash has 2 main parts in order to build an application. There's the UI piece, what's going on the screen. And that's probably the simpler part to understand. So you can see on the right-hand side, just a very simple code snippet where you import that Dash library. And then this layout piece is where we define the stuff that goes on the screen. So this is a super, super simple application. We just have an HTML div. For those of you who are web developers, that's just like a container on the page where we're putting our stuff. And we have a drop-down. We just say, what are the different options the user can choose from, and what's that starting option? And then down below, you can actually see what that app looks like. So to just break this down a little bit more, I would categorize these components into a few different types. First and foremost, you have just the page content, like the stuff that makes up the real estate on your screen. So those will be your containers, your HTML, just kind of like the UI stuff on your page. And probably the most important type of component within Dash, the control components. These will be your things that the user can interact with, things like sliders, drop-downs, buttons, radio items, all sorts of different things. And we ship with a ton of different components in our open source packages. We have Dash HTML components and Dash core components that give you these UI controls. You can also bring in your own components as well. So if there's a community package out there that you want to incorporate into your app, just install that library. It's as simple as that. If you have your own custom component that you want to build, I don't have time to talk about that today. It's a little bit more of advanced of a topic, but there's a whole docs page on how to create your own custom UI components to do exactly what you want. So again, not a fixed solution inside a small box. You can really build whatever you want with the Dash framework. Now, probably the most important concept to understand, the interactivity piece. How do we make our app actually do something? And that's through those callback functions. So they're pretty simple conceptually. You say, what are the inputs that the user can interact with? What are the outputs that we're going to update with those functions? and what's the code we're actually going to run. And just to talk about how these work under the hood a little bit more, usually you'll be reading data from somewhere, and then these callback functions are the mechanism that retrieve that data dynamically. So you load that data into the application server, and what's really nice about Dash, it's a web app. So you just communicate with the server tells you the content to update, sends it back to the browser. You don't need to install any other applications on your computer. Just have a web browser, run that code, go nuts. Now, just really quickly, I want to talk through these callback functions and that mechanism that makes them work. So this page that you see here is our Dash in 20 minutes tutorial. Fantastic resource if you want to learn more about Dash after this talk. But the really important piece is, if I go in here, those callback functions. Right? So you just say @callback, that's going to let your application know, hey, this is a function that we should be kind of paying attention to. You say, what are the inputs that the user can play around with? So we say the name of the component the user can select. And we say the specific property, the thing that we're paying attention to from that object. And then what are the outputs that are going to get updated? So just to kind of put this in human language, we're saying, take those radio items. Anytime a value is changing, update our figure property, what's showing up on the screen, of our graph. How are we updating that graph? It's whatever we're returning back from this function. So here we're returning back a histogram, setting the x-axis to continent, the y-axis to be whatever the user selected, so that's the dynamic part. And then you can see that all coming together at the bottom here. So those are kind of the building blocks for how Dash works. Pretty simple conceptually. You build your web page using UI components, and then you make it interact with the callbacks. So we just walked through the tutorial really quickly, but let's talk through a little bit more sophisticated of an example. I'll make this a little bigger so folks can see it. If people want to access any of the code that we're talking about today, we have this GitHub repo, just plotly/-os workshop. It's all open source code. It's all stuff that you can install locally, start playing around with yourself. Now, I know we have a lot of data scientists at this conference, so this example is working with one of the classic data science data sets. We're bringing in the iris data set, and we're going to create a UI so that we can run different models using that iris data set. So just scrolling up to the top here, we're obviously importing Plotly to visualize. We're importing Dash, that gives us that interactivity piece. And we're also bringing in scikit-learn so that we can run our clustering algorithm. So in the interest of time, I'm not going to go into every single line of code in here, but just bear with me. Two main pieces, the layout and the interactivity. The layout is built just by defining in code what do we want to put on the screen. So first we have a drop-down where the user can select the first variable that they want to pay attention to. We have a second drop-down, same sort of contents. The user can choose the other variable they want to use for that algorithm. And we also have a text input. So the user can input how many clusters do we want to run for this clustering algorithm. And then we're going to visualize that in a graph and a table. And at the bottom here, that's how we make the algorithm actually work. Right? This is one of those callback functions. So the outputs that will get updated by this function are the graph and the table on our screen. And as for what the user can play around with, it's those same components we talked about earlier. Now this gets a little bit more advanced. In addition to inputs and outputs, you have these things called states. They're like inputs, but they don't automatically trigger the function. So you don't want the code to run every single time the user's making a small change. You might want to wait until they've selected everything they want to input into this algorithm. So we're making our drop-downs states. We're saying pay attention to these values, but wait to actually run this algorithm until the user clicks an apply button. And then down here, that's whatever code you want to run in that callback function. So we're doing that k-means clustering, and then we're visualizing it. We're creating a graph, and then we're returning back that graph and the records for the table. Now this is just obviously the code side of things. This tab here is where we actually have that application. And again, it's a pretty simple one. Just have a couple drop-downs, this text input, and then this apply button. So I can choose the variables that I care about. Maybe I want to look at like petal length and petal width. I want to have more clusters. I'm going to bump that up to 5. And then when I click apply, it's going to run whatever Python code we've written in the backend. So just like that, we have a fully interactive web app totally built in Python. No knowledge of HTML, CSS, or JavaScript required. Now that's obviously a very simple example. You can do a lot more with Dash. So this page here is our Dash gallery. This is a place you can go to see all sorts of different types of applications. One that I really like in particular is this one here, because it's so different from your normal graphs and tables. Here we have an image, and we're able to make some annotations on this, right? So I can type some, or rather I can select some data. The internet's being a little finicky, right? I can just highlight parts of this image, and then it's going to run a segmentation algorithm. And actually, if you go to the slides here, you can see a nice little screenshot that I prepared beforehand with ODSC. So a little shout out to the conference there. Right, so that's one type of application, is this basically UI for annotating an image. You can also work with 3D data, right? Like if you come by our booth, booth 7 in the expo hall, usually what I have up there is this app that's just a 3D rendering of a brain, right? So you can see a brain on the page once it loads. Let me actually just connect to my hotspot here. A lot of folks on the Wi-Fi. Right, so you can load one of these applications and then interact with an object on the screen. So I know the name Dash might suggest analytics dashboards, but it's so much more than that. It lets you build any sort of web application that you want. We also have an examples section of our website where you can see more apps that people have built in our community. What's really cool is that all these apps that we're showing are open source, fully accessible in GitHub. This is one that I really like showing, because it's, again, so different from the normal graphs and tables thing. This is technically a scatter plot, but this community member actually built this scatter plot in such a way that when you select these different points, it's showing you space missions and information about those different space expeditions. Right? So it's a scatter plot that's designed to look like constellations. So I really quickly want to go back to this slide here, because I know that in addition to this being a data science-focused conference, AI is kind of the star of the show this year. So how can you incorporate AI into these applications you're building? Well, one way is for the developers, and that's probably stuff that all of you are very familiar with at this point. You know, we've probably all heard the term vibe coding, where you can go to ChatGPT, Claude, can type in some information in natural language, and then it'll spit out some code for you. And hopefully that code will actually run. Right, so large language models, and just more broadly AI, are great tools for speeding up that development process. But I know that there's a tendency for folks to think of AI and large language models, Gen AI, as all kind of the same thing. There are tons of other types of artificial intelligence out there. Right? We saw that example earlier where we were running a clustering algorithm. We saw that image segmentation app. So think of Dash as that tool to build whatever front end you want in order to run those models. Right? You're not just limited to using AI for development purposes. You can incorporate that into the apps that you're actually building. So we have about 5 minutes left. I want to make sure that you guys know where to go if you want to find more information after this talk. First place you should go is our documentation site. We have really awesome docs with inline examples that you can play around with. Plotly.com/Python for the graphing library, and then dash.plotly.com if you want to learn more about building an application using Dash. We also have a GitHub. Again, it's an open source set of libraries, so you can go there, see exactly what's happening in those libraries, even potentially suggest some changes yourself. And then one of the best resources at your disposal is the community forum. We have millions of people using Plotly and Dash. Last time I checked, I think it was over 30 million downloads of our open source libraries every month. So huge community that's constantly growing. And community.plotly.com, you can go there, talk with other users, and see some examples of apps that they've built. Now, before we wrap up, I just wanted to say thank you so much to the ODSC team for running these conferences for us. It's been 10 great years, 4 years for me working with you guys. So I just want to give a huge shout out to the ODSC team for putting on these events. And also to all of you for joining these events. These conferences wouldn't be a success if we didn't have folks like you coming to learn and speak with us. So thank you all for attending today's session. Yeah, thank you, thank you. And with that, we have about 4 or 5 minutes left. I'll be up here for a few minutes if folks have any questions. Yeah, question over there.
Hi, I'm Anandi from World Bank. So we involve in creating dashboards for enterprise architecture data.
Wow.
So right now we have our dashboards on Power BI. So this looks very interesting for us. So we can create interactive graphs and custom graphs because there is a lot of limitation in the Power BI. But I would also like to know, do you have any built-in libraries for generating diagrams?
Yeah.
Architecture diagrams specifically?
Architecture diagrams. So there are a lot out there. Many of them are built by our community members. So off the top of my head, I don't remember the name of it, but I've seen a library. It's built on top of a JavaScript package, and it lets you build those kind of flow diagrams where you're able to select like a database icon, drag it to where you want on the screen, drag your edges between those different objects. So short answer is yes, there are packages out there. One thing I quickly mention is that while it is a Python framework, Dash is all Python, it's built on top of JavaScript.
Okay.
So if you want to use any custom components or functionality, you just have to kind of add that Python layer on top of it.
Sure, yeah. So, sure, thank you.
Yeah, you're welcome.
Yeah.
Any other questions before we wrap up? Okay, wonderful. Thank you so much for attending. Enjoy the rest of the conference.